Purchasing a motorcycle is a heavy physical and financial investment. You're literally strapping yourself to an exposed engine, hovering inches above cracked, uneven asphalt at high speeds. Yet the market offers no clear starting point. A new rider is immediately confronted by a decision tree that fractures into 20 distinct varieties of motorcycles. Most buyers make a precise, costly error at this stage. They select a machine based on cultural cachet, movie appearances, or visual appeal, completely ignoring the mechanical intent behind the design. Forcing a motorcycle to do a job it wasn't engineered for creates immediate consequences. Unmatched ergonomics guarantee severe physical pain, rider fatigue, and inherently unsafe handling conditions in traffic. To navigate this, we must recognize the first immutable law of motorcycle physics. Every bike exists on a strict operational spectrum between paved and unpaved capability. The second law dictates rider posture. There is a constant, unavoidable tension between aggressive performance geometry and ergonomic comfort. Finding the correct motorcycle requires ignoring the marketing campaigns entirely. You have to map your exact physical daily routine directly to a machine's engineered limitations. We start with the urban pragmatist environment. This involves low speeds, dense stop-and-go traffic, and constant tight maneuverability. Standard and naked motorcycles are optimized for this specific environment. They force the rider into an upright, neutral seating position with a straight 90-degree spine and relaxed legs. The severe trade-off for this low-speed agility becomes obvious on the highway. Naked bikes lack aerodynamic fairings. Fairings are the molded plastic shells placed over a motorcycle's frame to deflect wind. Without them, sustained highway speeds create massive wind resistance, acting like a parachute on your chest and causing rapid fatigue. Electric motorcycles represent the current peak of urban engineering. They run entirely on batteries and electric motors, offering instant acceleration and requiring almost zero routine mechanical maintenance. However, electric bikes remain geographically constrained. Current battery capacities introduce heavy range anxiety, and lengthy charging logistics make them impractical for sudden long-distance trips. At the opposite extreme of paved riding, we find the distance monoliths. These are built specifically to handle hours of uninterrupted, high-speed highway travel. Cruiser and touring bikes achieve this stability by using heavy frames and V-twin engines. A V-twin is a two-cylinder engine layout known for generating massive low-end torque, which allows the bike to pull heavy loads steadily rather than relying on high top speeds. The penalty for this highway comfort is paid in the city. Their massive weight and long frames make low-speed urban filtering clumsy and physically exhausting to manage. Mastering pavement forces a strict binary choice. You either sacrifice high-speed endurance to gain low-speed agility, or you trade your city maneuverability for highway comfort. Moving into high-performance environments, the engineering priorities shift entirely. Here, machines are built to maximize raw acceleration and extreme cornering clearance above all else. Sport bikes and motocross machines achieve these extremes. They utilize high-revving engines tuned for rapid power delivery, wrapped in highly aerodynamic or lightweight frames. The mandatory physical trade-off for a sport bike is the aggressive, crouched riding posture. It requires the rider to fold over the fuel tank, placing intense strain directly on the wrists and lower back. The absolute limit of pavement performance is the drag bike. It is built strictly for straight-line acceleration over short distances, extending the frame significantly to prevent the extreme power from lifting the front wheel off the ground. On the unpaved extremes, the environment demands a completely different architecture, leading to dirt bikes and enduros. Their engineering relies on high ground clearance and long suspension travel. Suspension travel is the vertical distance the wheels can move to absorb violent impacts from rocks and jumps without transferring that shock to the chassis. The absolute operational limit of these unpaved specialists is the law. To maximize weight reduction, they are stripped of headlights, turn signals, and mirrors, making them entirely illegal to ride on public streets. Selecting a precision instrument motorcycle comes with a guarantee. The very features that make it excel on a dirt track or a racing circuit will make it physically miserable or legally impossible to use for a Tuesday morning commute. This friction leads many buyers into the jack-of-all-trades trap. They want a single motorcycle that seamlessly transitions from smooth highways to jagged dirt trails. Adventure and dual sport bikes attempt this exact compromise. Manufacturers take off-road capable suspension frames and bolt on the heavy electronics, lights, and emissions equipment required to make them street legal. This bar chart shows the primary physical consequence of hybrid engineering. By combining long travel suspension with street equipment, adventure bikes massively increase seat height, preventing riders from planting both feet safely at lights. This high center of gravity also introduces instability on the pavement. When applying hard brakes, the tall, soft front suspension compresses downward, a motion known as dive, making emergency stops difficult to control. Then we reach the ultimate marketing trap, selecting a motorcycle purely for its aesthetic value over its mechanical function. Bikes like choppers and bobbers are defined by their visual individuality. But extending the front forks and stripping away protective bodywork inherently degrades the turning radius and destroys the smoothness of the ride. Similarly, café racers force an aggressive, sport-like racing posture onto vintage, unrefined frames. The minimal design is inspired by 1960s racing culture, but it actively maximizes rider discomfort. Prioritizing a vintage or custom appearance means the rider must accept a severe, measurable tax on safety, handling, and daily practicality. Because of these strict physical trade-offs, for any given individual, 80% of the motorcycles on the market are the wrong tool for the job. This chart maps a scenario match matrix used to filter out incorrect options based entirely on environmental reality. For beginners and urban commuters, engineering requirements are agility and approachability. Standard, naked, and mini bikes populate safely in the high-comfort, pavement-only quadrant. Experiential distance riders require heavy DB stability to prevent fatigue. Cruisers and touring motorcycles sit at the absolute edge of maximum comfort and pavement exclusivity. Riders who genuinely split their time between asphalt and trails land squarely on the center line. They utilize adventure and dual sport bikes, provided they are tall enough to manage the height compromise. This leaves the strict exclusion zone. These are the highly specialized, uncompromising machines that the average buyer must aggressively avoid. Venturing into this low-comfort territory is only viable for experienced riders who are actively willing to trade their physical well-being for pure track speed or niche vintage styling. A successful motorcycle investment happens only when you stop shopping for an identity. You find the right machine the moment you buy the engineered solution that matches your literal daily environment.